So let us start by creating a string. I will call that string variable name message. And in that, I will put this string called, how are you doing today? You know that I can do string concatenation like this to add something to the existing string. Of course, I can do some more concatenation. This, is the new line. So now a string is ready. There it is. Now we shall learn about a string method called split. So I'll make another variable called message paths. This will be a list that we will get from using the split method on the string being message, and we are using the split method on the string to get the paths into a list, all right? Once you do that, you can print the message paths. This is how it will look. By default, split will split on a space. So you can see them here. They have been split into words wherever it encounters a space. Okay, so the today and comma, one part. All right, the class and question mark is another part. It also splits also a new line. This split by default splits on white space. But I think I told you that white space is basically tabs, new lines, and spaces. Since we have a new line here, the hope and the class question mark got split. Now you could choose to split not on the default white space, but on some other character like a comma. So if I do this, you will see only two parts. This is the first part and this is the second part, because comma appears only once. Therefore, you get only two parts. Let us do one more. I can split on a new line like this. Then, of course, you'll get two parts, the first sentence and the second sentence. Now, we'll learn about another method called strip. It strips off the string from any white space in the beginning and the end. So leading and trailing white space is what gets removed with the strip function, or the strip method rather. I'm going to make another one here called padded message, putting some individual spaces as you can see, and then I'll put some tabs as well, some more spaces. I will concatenate the message and I'll put some trailing space, tab, and new line as well. So there's a lot of leading white space and a lot of trailing white space as well in this new padded message, right? This is what it looks like. You see the leading white space, but you don't see the trailing because it's not visible. But if you do a selection, you kind of see it. You also see the new line because there's an empty line here. In order to get back the original message, we can do that by stripping this padded message. So padded message dot strip, there you go. I showed you how to split it into a list. What if you wanted the list backwards? That you can do by using a method dot reverse. Oh, because message parts basically, so again, this is something you need to remember. Some methods do not return anything. Some methods do not return anything, but do whatever it is supposed to do in place, meaning it alters the object itself, in this case, the list itself. So that is why you see a none here. So you can't help it in this case because it doesn't return anything. You can't even assign it to a variable. You have to do it in place. And then you can change the name later, of course. If you want to change the name, you could do it here. Okay. Now you can print reverse message parts, and it does it, right? But then the thing is that with these kind of methods, you don't really have the choice. You have to do it in place. Now, we want to learn about slicing. And when you know how to slice strings and lists, basically the slicing procedure is identical across all objects. Every iterable, every collection can be sliced in the same way. There may be some exceptions, which we will deal with when we get to them. but otherwise, most of the cases, the slicing procedure is identical. Now, I can take a particular slice out of this list or out of the string, okay? So let's do it for the string first. What I want is to extract just the today part. How can I do that? I need to know the index of this t and the index of this y, okay? That's what will get me today through slicing. So slicing, the notation is like this. You use a square brackets for square bracket pair for slicing. You mention the first index here, separated by a colon, and then the last index, okay? So this is 0, as you know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right? So we go from 18 till 19, 20, 21, 22. So you mentioned 23 here because it goes one less than that. There you go. You can also do a slicing on message parts. That is a list. You want to get just today from here, okay? Just this one again. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So you just say 9 here. That'll give you today, right? Today, comma, though, right? Because that's what's in here. What if you wanted just today, right? You can do that as well. So you say 9, and then you put another like this, because this one, you know, will give you today, comma, right? And then that is a string. So you use one more set of parentheses, square brackets here to do this kind of slicing now, because this is a string. It is same as doing this, a string and then a string slicing. That should give you today. -1, by the way, is a way in Python to denote the last item, all right? So if you're thinking going from the first item to the last item should give you today, comma, you need to remember that the ending index is always either one less or one more, depending on which direction you're going, or if you're using negative indexing here. In this case, it's negative indexing. Of course, I showed you the reverse method of list. You can actually reverse a list without reverse method, okay? All you need to do is slicing. So you can say go from -1 to the beginning and go -1 step each time. So it's saying -1, I told you, is the last item. So it goes from here and to the beginning. We don't mention anything here, means till the end. So if it is starting from here, the end would be this one, right? And then because it is going the reverse direction, you have to mention the step as -1. Go 1 minus each time, okay? That should work. So there you go. You have the original list back. Of course, you can do this with the string also. Instead of the list, we are going to use the string and do this. So what does this give us? It gives us this string in reverse. It starts from exclamation, then S, then N, and so on, till H. H would be the last one, okay? So you see here, this is the exact reverse of that string. Now we'll do a little exercise. What we want to do is, we have this string, I'll just call it string, and this string contains this string, okay? What we want as output is this. Basically, it's the reverse of this, excluding the punctuation, the comma, and the exclamation mark. So first we will clean the string, meaning remove the punctuation. So we're replacing the comma with a null string. Okay, this is called a null string. There is no space, nothing between the two quotes. Whatever you are replacing, actually you're removing. You want to remove the exclamation mark also. Now you will see when I print the clean string, what I get is an error, Okay, so this I have not run. Now you get this without the punctuation marks. That's very easy to do the reverse, right? To do the reverse, well, you can do it in so many ways. I'll first show you a naive way. You can create first a list, string list, and you can use a loop going character by character in the clean string, but instead of going forward, we'll go backwards. Backwards would be -1 to everything, going one step reverse at a time. We will add this character to the string list. And then we can have a look at it. There you go. Now all we have to do is add dashes and convert this list into a string. So we'll call this output string now. The output string will be equal to the dash dot join, and the join takes a list. Okay, we already have the list here. This is our list, right? So we can pass this in here, and then we can print the output string. So now you see you got the string that you finally wanted. If you want to see this as this, what do? We can go from the start to the finish by going 2 steps in the reverse direction. So that naturally means I go from the last to the first, going 2 steps at a time. Okay, so I'll start from here and end here. Instead of going 1 step at a time, I'll go 2 steps at a time. So this will basically give you honeybee. We'll learn about another string method called find, which is again very useful, very widely used. Now let's say in this message, we want to find the word in. We want to find where does it occur? Does it occur or not? So you see it tells us that it occurs at position 14. So if you count from here 14, you will see that this is 14. Okay, this I is 14. So from here you can understand that it doesn't have to be a separate word. It can be a word inside a word, right? It can be part of a word, but it can be a separate word as well. So let's find R. There are 2 R's here. Which one do you think it'll find for you? It'll find the first one, of course. What if we want to find the second R? Then we can start at 5, because we know the first one starts at 4. Then it will start looking from here and the rest of the string. So it'll not find this first R. Okay, it'll find the second R. If you run this, you get 41, and 41 is the index for the second R. Now, what if I want to find another R? I know that there is no other R, right? That was the last one at 41. But what if I want to? What if I'm putting this find thing inside a larger program where I don't necessarily know how many R's there are, right? So I might be doing like each time I'm doing a find, I'm updating this number to the last find index +1. So right now I will do 42, let's say. Okay. So if I do 42, it will start looking from here to the rest of the string. It will not find any. So what does it tell us when it does not find any? It says -1. That means it did not find any. Now, would it not be nice if there was a method similar to find, but which would find for you all the indexes of that word, like R is at 4 and 41. So it would be nice to have a function or method like find all, like you have some in some word editors like find all, right? Code editors, word editors. But unfortunately, Python does not have such a method called find all. All there is find. So we are going to write a UDF to find all indices of a substring in a string. Okay, The substring being whatever you're trying to find, and the string being wherever you are trying to find it. So we'll define a function called findall, and that will take a string, we'll call it main string, and it'll also take a substring. So how do we do this? We first need to create a list called list of index, let's say, okay? That we initialize to an empty list, and then we find the first occurrence of the substring in the string. We can call that substring index. That we set equal to the main string dot find, and find what? Substring, right? So the first time we find it, we just do it just like we have done it here. Instead of using a particular variable name and a particular substring here, we are substituting both those things by variables that we are getting as input to the function, okay? This and this here. Otherwise, it's very much like what we have done previously. Now you need to check if this index is -1, right? Because there's a chance that the substring is not found. So while the substring index is not -1, we want to keep finding it, right? We want to keep repeating that. And we have already found one. That means if it is not equal to -1 and it comes here, it means that it has already found one. So if it has already found one, we add that index to this list. So we do an append here, and we add the substring index. And then very simply, we look for it again, same thing that we did, but with one more parameter, the substring index that it found the last time, +1. Now we are ready to return the list. That would be list index. This should work. Now we can call the function like findall. We give the main string here as the first parameter, and the substring as the second parameter. So what you can expect from this is a list that contains 4 and 41. Okay, let's see if that is true. There you go. So you get 4 and 41. I can show you one more example here. Instead of R, I'll take in. That'll give us 4 of them, right? Because in appears 4 times, it seems. Okay, you can count later.